So this class, it will be going for the YouTube channel. Okay, so let's start the session. Okay, so there is also a session for us that is a mentor quest where we are doing live question and answer writing session. So if you are interested, then you can join that session. There is a session for case study, okay, where we are discussing case study specifically. You can join that session too. Okay,
Okay.
so yeah, have you appeared for prelims this year?
Yes, sir.
Okay, so how was the prelims?
It was good as compared to last year.
Okay,
Um, Scoring near about 77 or 80.
okay,
Yes, sir.
okay. So let's discuss this after the session. Okay,
Okay, sir.
okay. Now let's start this session here. Okay, to so welcome to Civil Prep. Okay, Civil Prep. I have started this institution for geography optional specifically because I have been teaching geography optional since a very long time. So today we'll be discussing a case study for the variability in Indian monsoon. You might have heard. You can mute your audio. Okay, thank you. So this is a case study on the variability in Indian monsoon. Now, what we have seen this year, you might have also seen in the news that the monsoon in India, it came quite early, okay, compared to last few years. Okay, so today, if we look at it is 3rd June and monsoon has already crossed Western Ghats. Western Ghats, I will not be saying Western Ghats, it is not proper, but I will say Pune 2 days back, and it is approaching fast towards the Indo-Gangetic Plain, the Madhya Pradesh region, and it will move quite fast to the other regions, that is the Himalayan foothills. And this will be quite fast here. Okay, so therefore we need to understand that why this is happening so fast. Okay, so we have started this session. I have kept this session for this part here. So starting here with the first part here. So this is Monsoon 2025, a systematic and regional analysis where we'll be doing the systematic things. We'll be looking things systematically and on the regional scale also. For example, in the Northeast India, in the Northwest India, the Western India, the Deccan India, this Southern India, okay, also Central India. So what it is forecasted, this all this data has been taken from IMD and other websites. So they have said that this year it will be 106% of rainfall, which will be higher than average. Okay, this will be higher than average, and this is predicted. Okay, so prediction is done here, and prediction is done on what basis? It is done on various models. Okay, what are these models? We'll be discussing them in the coming sessions. Okay, now what has been done here? IMD has also seen various data related to ocean atmospheric conditions. Okay, ocean atmospheric conditions, for example, the sea surface temperature, then the wind circulation, then the temperature of atmosphere, then the conditions of ITCZ, the conditions of Tibetan Plateau. Okay, so all these things have been taken into consideration along with the physiography of India, which is quite constant. Other things or other variables, when I talk about, they are quite dynamic, like sea surface temperature, wind circulation, Okay, wind circulation, it is also dependent on ENSO cycle, that is El Nino and La Nina. Then we also have Indian Ocean dipole. This is also one of the condition which is impacting all this monsoon area. Therefore, what we see here that the system of monsoon, it is working like a system. It is having certain input and it is having certain output. Okay, output here it is getting varied depending upon the variables which are present here. That is sea surface temperature, wind circulation, ENSO cycle, and Indian Ocean dipole. There are other factors also. Yes, there is ITCZ. It is also one of the factor. Tibetan Plateau. It is another factor. Then we have subtropical westerly jet stream, okay, which is present near the Tibetan Plateau, just above the Himalayan region. So these are the factors which are working as an input for the variability in Indian monsoon. Okay. Then we'll be looking at regional variability, scientific modeling, and geographical implications for this part. Now moving further, here we'll be seeing that what are the scientific models which are helping us to predict this forecast in a better way. First is the multimodal ensemble. This is one of the model which is currently being used. Okay, this model along with the coupled global climate model, this is also being used for the prediction of the winds, the sea surface temperature, okay, whatever things we have seen before. Then the most important part here, that is monsoon mission climate forecasting system. This is one of the most important part, and this is not only India is doing this. India is part of this basic system, but there are various other countries which are part of this system. That is monsoon mission. This is the major mission, that is a monsoon mission. Under this, we have monsoon mission climate forecasting system. So there is a parent, we can say the parent mission, that is monsoon mission, under which monsoon mission climate forecasting system is being kept. Now here we'll be seeing that previously the question have been independently asked on monsoon mission. Okay, so we need to know certain things about monsoon mission and who, what are the international organizations and countries who are associated with it. Now this thing will be seeing that it is a probabilistic regional projection. Okay, so one of the part we have studied in the human geography, that is probabilism. Now probabilism will be saying that it is one of the outcome of positivism. Okay, positivism, it is a scientific theme. Okay, and under this scientific theme, there is a probabilism that what can be the probable outcome of this particular interaction of various components of a system. Okay, so this is seen here. Then monsoon ENSO hypothesis, which was provided by Sikka and Gadgil. This is also important for us to understand. Okay. Then Walker circulation model, which is nothing but the ENSO cycle. Okay, this is the ENSO cycle. Now, these complete models, they provide us a basic theme where the monsoon system is being understood from the different dimensions. Now, what are these different dimensions? We'll be looking here. Number one, here we have the first thing, that is regional climate pattern, that is forecast here. Okay, regional climate pattern and forecast. So here we see that we have a regional basis. I will be just highlighting here. For example, below normal, normal, and above normal. So this data is being taken from the IMD. Okay. So here we can see that the Jammu and Kashmir region, the entire Northeast India. Okay. So these are the two regions which are having below normal rainfall. Okay. They will be having below normal rainfall, while we will see that the Western India, the Southern India, they will be having normal to above normal. Okay, they will be having normal to above normal rainfall. While the region of Himalayan regions and the Tarai belt, they will be having normal rainfall in this condition. Okay, so we can see from this data also for central and peninsular India. Okay, central and peninsular India. Okay, this one is the central part. We have 106% of rainfall above average. Then northwest India, here we have 92 to 108%. Then northeast India, it is 94%, that is the below average. This is the below average condition where which this region will be rainfall deficit. Okay, this type of conditions, okay, this type of, I'll just change the color here. Okay, so here we can see that there is a condition where the rainfall pattern is being assessed. Okay, the rainfall pattern is being assessed here. This type of mapping, it is called as isohetal mapping. Okay, this is basically one of the quantitative tool. It is used to look at uh, the rainfall patterns and form a lines. Okay, iso means basically they are connecting dots, okay, where the rainfall will be quite same. So this is called as isohetal mapping, which is the determination of rainfall, or we can say precipitation. Okay, so in this way we are able to see that where which are the regions where the rainfall will be deficit and which are the regions where the rainfall will be quite high here. Okay, now we will see that what is the impact or what is the analysis of this particular condition what we are seeing here. Okay, so here we can see that, okay, so this is the condition. Here we can see that what is happening in this part. Now we will be coming to the next session, that what is the analysis of this thing. So first thing it is saying that here in the northeastern part of India, there is big trough and low orographic effect. So what is mean by big trough? What is the trough in the monsoon? Can you explain what are troughs in the monsoon winds? Trends? Am I audible? Varsha, am I audible? Yes, audible. Okay. So monsoon trough, are you aware about it? Okay, so here we will be seeing that when we draw the map of India, okay, so here we see that the winds, okay, they move almost like this. These winds, they are moisture laden. and they move in a wavy pattern. Okay, therefore they are called as monsoon troughs. Okay, they are called as monsoon troughs. Okay, so this is one part. Now, low orographic effect. What is orographic effect? What is orographic effect? This is a mountain. Okay, so here we see that the mountains, the clouds they climb, and when there is an interaction between this cloud and this mountain, so under that condition, the rainfall occurs here. The rainfall occurs, okay, and the same cloud when it moves outside, okay, when the rainfall occurs, the clouds they cool up, and as they cool, they expand. Okay, as they expand, their moisture carrying capacity declines. So the clouds which come to this side, okay, that is the leeward side. Here the moisture carrying capacity of this cloud, it declines. Okay, so this results into a low rainfall pattern. Therefore, we'll be seeing that in the regions of uh, the Western Ghats, okay, the Western Ghat region, the region which is behind the Shivaliks. Okay, so here the rainfall it is quite low. Okay, also in the Thar or desert region. Okay, Thar desert region, here the rainfall is quite low. Now, moving to next part. Here we'll be seeing that in the Madhya Pradesh and Maharashtra region, the rainfall will be above normal. So in the news, we can see in the contemporary time, that is the region of Mumbai, the region of Konkan, also Pune. Okay, so here the rainfall is very high. Okay, here the rainfall is currently very high and it is predicted above normal. Similarly, we'll be seeing that the region of northwestern India, okay, when we see here the region of northwestern India, this part, here also we'll be seeing that there is surges will be present there and the western disturbances will be helping the rainfall to increase. Okay, western disturbances they are prevalent in this time period also and they will increase the rainfall in the northwestern India. Now in the southern peninsula there is enhanced cross equatorial flow. Okay, cross equatorial flow means when we have this region we have 0 degree equator at this part and here we have the movement of the uh, we can say the movement of the winds is taking place from southern hemisphere to the northern hemisphere and this will result into the uh, increase in the moisture laden wind in the northern hemisphere and Indian region. Okay, so here we see that with this system, what are the theoretical frameworks which will help us to understand this particular region here? For example, the dynamic concept. Okay, the dynamic concept in the climatology, it was majorly given by Phone. Okay, you may remember it. Do you know about Phone? Phone has given three concepts here. First is of jet streams, second was of ITCZ, okay, and third was of we will see here the Hadley cell. Are you aware about it, Varsha? You can unmute and you can speak.
Yes, sir.
Okay. So tell me what was the concept of phone?
Which one, sir?
Of phone's concept. Phone. The dynamic concept of phone.
Sorry, sir, I don't remember right now.
Okay, not an issue. Okay, so he has given this concept where he has included jet stream, he has also included ITCZ, and he has also talked about the pressure belt system. Okay, the pressure belt system and the shifting of pressure belt. This was also talked about in the dynamic concept of form. Then there was a intraseasonal MJO, that is a median Julian oscillation. Okay, so it basically helps in the active cycle or the break cycle of the monsoon period. Okay, then the monsoon variability, it also have an impact on the agricultural system of India. So here it can be interlinked with the one tenants model, where the shifting pattern of agriculture can be seen in India. Okay, we'll try to correlate it here. Then a spatio-temporal analysis, it can be made here with respect to India, that what is the trend of above average monsoon and what is the trend of below average monsoon. Okay, so this is above average and these are below average. So we are saying that in the year of 2025, it is above average. In the year of 2024, also it was above average. But in the year of 2023, it was below average. In the year of 2022, again it was below average. Okay, so after a lot of years we are seeing that there is a above average rainfall in India. Okay, there are certain anomaly maps in the region of India where the high rainfall is taking place and there is a low rainfall is taking place. We'll be understanding it further. Okay, now we will see here that there are certain reasons for the causes of variability of monsoon in 2025. Okay, you might be aware of this ENSO cycle. Okay, that is El Nino and La Nina. El Nino and La Nina. You can speak, Varsha.
Yes, sir.
Okay, so this is the Pacific Ocean. This is Pacific Ocean. Okay, this is Asia. This is Australia. This is North America. This is South America. This is almost equator here. Okay, so this is Pacific Ocean. In this Pacific Ocean, we have two sections. We have two sections here. One is the Eastern Pacific, Western Pacific, and another is the Eastern Pacific. So when the temperature of the Western Pacific and the Eastern Pacific, it is same. So this is the condition of a neutral condition. When the Western Pacific, it is higher than the Eastern Pacific, it results into the rainfall in this particular region. It is the condition of a La Nina. And when the Western Pacific, it is less than the Eastern Pacific, it is a condition of El Nino, where the rainfall in the Indian region, it is low. Under this, the rainfall in the Indian region, it is high. But in this neutral condition, the rainfall in the Indian region, it will be normal. Now, this is a normal condition. This is a normal condition. But still, there is one more thing that is happening here. That is negative Indian Ocean dipole. Okay, there is a negative Indian Ocean dipole. Now when I'm talking about Indian Ocean dipole, I'll take another page. Okay, this is the region of India. Okay, I'll just take this part. Okay, this is the region of India. This is equator. So we see that this is the complete region of Indian Ocean. Okay, at this point we have Arabian Sea, and in this region we have Bay of Bengal. So here what we'll be seeing that we have a complete region where we have two poles with respect to Indian Ocean. Okay, this is the complete Indian Ocean. So there are two poles can be seen here. So because of these two poles which are formed here, certain times the Arabian Sea, it has temperature greater than Bay of Bengal. This is called as positive Indian Ocean dipole. When the Arabian Sea having temperature less than Bay of Bengal, it is called as negative Indian Ocean dipole. When the temperature of Arabian Sea and Bay of Bengal it is equal, it is called as neutral Indian Ocean dipole. So in this condition, what we are seeing that the Bay of Bengal region, it is having a higher temperature compared to the Arabian Sea. Therefore, it is a negative Indian Ocean dipole condition. So here we can see that the condition here is negative Indian Ocean dipole, which is in the developing stage currently. Okay, and before this, it was a neutral condition. It was a neutral condition. In the year of 2024, it was a positive condition. So it went from positive to neutral. Now it is going towards the negative condition. Okay. So in this negative condition, what we will see here, the temperature of the Arabian Sea, it will be quite lesser. It will be comparatively cooler in the Indian Ocean region, while the temperature in this region of the temperature in the Bay of Bengal region, it will be comparatively higher. So under this condition, what will be seeing that in this two region, the moisture which is present in the atmosphere in this Arabian Sea region, it will be low, while the moisture in the Bay of Bengal region, it will be high because of high temperature, okay, because of low temperature. Okay, so because of this condition, what we will be experiencing here, whatever the winds are coming, okay, I will take this one. Whatever the winds are coming here, I'll change color. Just give me a second. These winds, they will be picking up moisture, okay, and they will be moving towards northeast India, and they will be moving towards the central India, okay. Now, similarly, what we'll be seeing here, that this region, it will be having this region, it will be having this particular setup of wind pattern, and they will be moving inside, they will be merging near the central India, and they will be moving towards the Himalayan region. Okay, so this is a normal pattern of monsoon movement. So because of this one of the condition, we will see that in this particular region there is increased rainfall in this area. Okay, there is increased rainfall in this particular area. But why there is low rainfall in the northeast region of India? This is also one of the conditions. See, Here we'll be seeing that it is also influenced by the wind system and the orographic conditions which are present in the northeastern part of India, which will result into the negative condition. Okay. Madden-Julian oscillations. Are you aware about Madden-Julian oscillation?
Sir, but one doubt here.
Okay, you can ask.
When there is positive Indian Ocean dipole,
Mhm.
it result it results in the good rainfall in India, right?
Right.
But as we have seen in 2025, we saw that there is a early arrival of monsoon, and there,
Yeah.
as you told right now, that there is there will be enough rainfall. This kind of prediction. So why is there negative Indian Ocean dipole in 2025?
Why there is negative Indian Ocean dipole in 2025? See, this
Then
condition,
yes,
this Indian Ocean dipole, it does not depend upon monsoon. It is basically a climatic phenomena which is happening right now without knowing us. We do not know the actual cause of their rising. It can be, we can say, the Arctic oscillation, it can be Atlantic meridional oscillation, it can be ocean currents, it can be ENSO cycle, it can be Atlantic cycle, Arctic cycle. Okay, there are thousands of factors which actually result into the variation of the temperature of any region. So it is like we cannot predict that what is the actual reason for the negative Indian Ocean dipole developing in the later phase. Currently, it is neutral Indian Ocean dipole, but it is moving towards negative. Okay.
okay, sir.
Okay. So first thing was that, and you were asking that if the monsoon, the Indian Ocean dipole, it is negative, then why the monsoon is getting stronger? This
Yes,
is
sir.
yeah. Okay. So this is one of the analytical question. This is a good question. Now, what we are seeing here that this is ITCZ. I'll just take it a bit downward. This is ITCZ. Okay. In this region, we are seeing that this is a cooler region. Okay. This is a cooler region, while this is a warmer region. Okay. Here we have a Tibetan plateau. Now, what we are saying that as ITCZ it is in its place, okay, this region here it is cool, this region here it is warm. So what we are saying here that there is formation of a comparatively high pressure system in this region, and there is a comparatively formation of low pressure system in this region. So whenever there is formation of high pressure and low pressure, we always know that the winds they always move from high to low, and the region as it will be having a contrasting high and low pressure region, the winds they will become more stronger. So this is one of the reason because of which we will be seeing that the monsoon winds in this region they have grown more stronger because of the presence of this high pressure system or high pressure region. Are you able to understand this?
Yes, sir. Got it.
Okay, so this is the reason why the monsoon winds they are growing more stronger here. Okay, so next point here we have Madden-Julian oscillation. You might be aware about the Madden-Julian oscillation. It is moving from the region of Africa. Okay, so here we have the region of Africa. So from Africa we see that the Madden-Julian oscillation it moves towards the, actually this is quite near India. It is in the southern hemisphere. Okay, and this Madden oscillation, it moves towards the Pacific Ocean, towards the Western Pacific, and it then goes off. Then another oscillation cycle it starts. Okay, so this is one of the condition where the oscillation occurs in this particular region. So this also impacts the movement of monsoon winds, because we have a masculine high here. Okay, not here. We have masculine high in this region. Okay, so this masculine high, it is quite responsible for acting as a high pressure system and supplying moisture to the Indian region. Okay, then after this we have Tibetan high shift. So here we have seen that we have low pressure system in this region, in the Tibetan plateau region. Okay, not this one. This is the Tibetan plateau region where we have the low pressure system. Now, during the colder region, when the region is cold, the high pressure system in the Siberian region, it shifts towards the Tibetan plateau region. But as the movement of sun, it occurs towards the Tropic of Cancer. Here, the high pressure system, it shifts again towards the Siberian region. Okay, so this is another factor. Then ENSO IIT teleconnection. Now, what we will see here that this region, it is having quite neutral condition. Okay, temperature here, it is not very profound. Okay, the temperature contrast, it is not profound. And in this region, what we are seeing that here there is cool condition, here there is warm condition. So because of this condition of ENSO, that is El Nino and La Nina, and Indian Ocean dipole, there is a mixed circumstances. Okay, there are mixed circumstances, which is basically acting towards the better formation of monsoon this year. Okay, so are you able to understand that what are the reasons which are helping India to develop uh, the stronger monsoon winds?
Yes, sir, got it now.
Okay, so there is another factor. If the Western Pacific, it had been more warmer. Okay, if it would had been more warmer and there had been the negative Indian Ocean dipole, so it would have made all this region very warm. Okay, and because of this mixed conditions, this is also warmer and this is also warmer, it would have increased the monsoon variability and monsoon rainfall in the Indian region. So this is one of the factors. These are the factors which are impacting the Indian monsoon here. And in this 2025, we have these conditions which are actually happening. Now, what is the impact of this variability in monsoon? Now, impact will be seeing that it is very high in the agricultural part. So there are two kind of impact. Number one, there will be high productivity. Okay, as you can see that it is a summer season and we have paddy, that is rice, cotton in the region of Maharashtra. Okay, in the region of Madhya Pradesh, also Gujarat, southern part of India. Okay, rice is highly grown there. Not in Maharashtra and Madhya Pradesh. Madhya Pradesh, it is wheat. Rice will be grown in certain regions, but cotton is grown there. Okay, in the Maharashtra region, the cotton is grown in this particular region. So it will give a high boost and high productivity. Second thing, what is the issue also? Because of high rainfall, it will also result into floods. This is the another important factor. For example, in the Pune region, in the Mumbai region, the region they are already witnessing floods right now. Okay. So similarly, as the monsoon will move forward, it will result into the floods in the Madhya Pradesh region, again in the region of Himachal Pradesh, Uttarakhand, okay, the foothills of Himalayas, okay, in the Delhi region, okay, in the northeastern region, as the monsoon has reached already Arunachal Pradesh, it was today's news. Okay, So floods, why they are happening? It is happening because of the extremity. Extremity is happening because of climate change. Okay, large amount of rainfall. Okay, when it is spent from, we can say, June to September, it is concentrated in patches, and these patches, they are providing rainfall in this particular region. So we will see that if it is 100 centimeters spent from June to September, it will be 50 centimeters just in 1 month and 50 centimeters in another month. So here we see that the rainfall, it is becoming extreme, and therefore it is causing floods. But overall we'll be seeing that the rainfall in this region of northeastern India, it is lower than average. It is lower than average here. Okay, then crop productivity, it will be higher, but there will be disease risk also. Okay, because of the increased moisture, because of increased moisture, there is a risk of certain diseases in the crops also. Then going forward, environmental and hydrological impacts will be seen. Flood risk, as I have discussed, Konkan, already there is flood. Assam region, there is flood because of the Brahmaputra. Bihar, because of Kosi. Okay, so here the floods will be seen. Urban flooding, Mumbai, it is also already witnessing floods. Bangalore, it will witness floods in the coming months. Okay, now one thing is quite good here. There will be recharge of the reservoirs in the central and the peninsular India. Okay, so here we'll be looking at integrated management of flood system. Okay, now after this infrastructure and health concerns, the high rainfall, it will disrupt the transport communication. Okay, for example, in the Himalayan region, okay, then we have Western Ghats as well as Northeast India. Okay, Northeast India, if there is floods, it will impact the region, but the Himalayan region and the Western Ghat region, they will be disrupting the transport system. Waterborne diseases like cholera, typhoid, dengue. Okay, so this will be certain diseases which will be increasing here. Flood risk, it is already high. Okay, whatever the river regime states are there. Okay, the river regime states, here the floods are quite high. Droughts in the northeastern India, as we have already discussed. Okay, there will not be droughts actually, but there will be certain regions. Okay, certain regions of northeast India which will be witnessing droughts. There can be food security issues because of droughts as well as floods, because both the system, they destroy crops. Okay, both the systems, they destroy crops. When we talk about the food security, you can add up Malthusian view. You can also add here limits to growth. Okay, when we are talking about the diseases, these diseases, they are interlinked with human development index here. Okay, when we are talking about flood risk, so we are talking here about the disaster management. Okay, so here we see that this was the end part here. So if you have any doubt, any query with respect to this system, this part, you can ask me here.
So first of all, it was a good session.
Okay, thank you.
And sir, actually, what problem I'm facing right now is that I have covered all the syllabus and I
Hmm.
will revise it obviously. But during answer writing, what my problem is that I have also covered Indian geography, also the world geography, yeah, like human geography. Uh, I face problem in interlinking. Like just now when you talked about the security problem, there you mentioned about the Malthusian view.
Yeah.
I don't recall while writing that okay, I can mention this here, and this is something that fetch marks.
Okay,
So
no, sure. For the answer writing, we have Mentor Quest where we are doing live answer writing. Okay, I am providing question. Okay, the in the group, if you will go for Mentor Quest in today's link, so there are three questions discussed today. You can go through the session and you can view. It is very helpful for you because in that session we have discussed about how to approach an answer, how to include models, series, laws, and perspective in writing an answer along with the examples and case studies. Okay, so it will be very helpful. Join, just view that video, and tomorrow we'll be having another session. I'll be providing link so you can go through it. It will really help.
okay, okay, sir, I'll watch that.
Yeah. Okay, so Varsha, I will be concluding this particular session here. So this was basically a case which is actually happening in India this year. So it will give a good insight that how to approach for the monsoon in 2025. Okay, so see you tomorrow. Tomorrow we'll be having another session on another part. So I'll be notifying it on the group. Okay, so
Thank you,
all the
sir.
and take care.